the propeller, the right aileron, horizontal stabilizer, elevator, rudder, vertical stabilizer. Then it goes on at the bottom of page 2, it says gliders. Glider is actually a kite without a string. In 1804, Sir George Cayley discovered that a kite could be kept at the right angle by using 2 kites fastened together with a stick. The wind would blow over a single kite by picking up the front edge and flipping it over backwards. The addition of the second tail kite keeps this from happening. People have always wanted to fly like birds. The first record of a human to fly in a plane that was heavier than air was in 1849. The flight was in a glider, being pulled down a hill with a rope. A record-setting glider flight of 250 yards was set by a man in 1897. It is possible for man in 1897 to still be alive today. In 1988, he would only be 91 years old. Imagine how fast technology of air flight has advanced. We've gone from a flight of 250 yards to a flight to the moon. Otto Lilienthal, often called the father of modern aviation, he was killed flying an experimental glider in 1896. And I remember Otto Lilienthal, right after he crashed, he was laying there, hurt. He probably knew he was going to die, and they're going, "Oh, we're so sorry, we're so sorry." And he said, "Sacrifices must be made. Sacrifices must be made," he said. "If we're going to advance in this, we're going to have to make some sacrifices." Now that's pretty amazing. He was that dedicated to it to where he was willing to sacrifice his life. That was his famous quote, "Sacrifices must be made." Okay, a balloon's not really flying. It is floating. Many people see a balloon up there and they go, "Oh, look at the balloon flying in the air." It's not. It's floating in the air, just like a boat floats in the water. Okay? They call them heavier than air. It's a whole different license to fly a balloon than it is an airplane. Leaving the Earth. About 200 years ago, people and animals lifted off the Earth in hot air balloons. The hot air made the balloon rise. Heat was obtained from open fires beneath the balloon. The first record of such a flight dates back to 1783. The astronauts were several farm animals. The distance traveled was about 2 miles. The experimenters were Joseph and Étienne Montgolfier. Later in 1783, Jean Rogier and French Marquis flew a hot air balloon 3,000 feet into the air for 25 minutes. Okay? Obviously, heat rises. That's why whenever you see smoke, it's going up. The hot air balloon, it takes the hot air, it's lighter than the cold air, and gets it to float, to fly. Over on the bottom at 3, have you ever thought about what it means to fly? Just because something goes through the air doesn't mean it's flying. Jumping into the air or throwing a ball isn't really flying. Flying is when an object travels through the air using wings to give it lift. An object that is pushed or propelled by a force may be traveling through the air, but technically it's not flying. Which objects are flying? Hot air balloon? A 747 jet airplane?
Yes.
Yes. An unmanned rocket?
Yes.
A quarterback's pass into the end zone?
No.
A large bird or a small bird?
Yes.
Okay. So then on the next page it gives the answers to those. And it says only the airplane and the birds are really flying. Balloons are lighter than aircrafts. Lighter than aircrafts will rise until they displace their own weight of air. When they reach that level, they float in air like boats float in water. A boat floats in water when it can take the place of the amount of water equal to the weight of the boat. This is called displacement. Balloons had one major problem. They couldn't be steered. Some people suggested trained birds pull the balloons. In 1852, Henry Gifford mounted a small steam engine on a balloon that had been filled with hydrogen. The dirigible was born. The dirigible, hydrogen-filled, like the Hindenburg. Okay? The bummer of that is hydrogen is very explosive. Okay? And it can blow up. The Mythbusters did it. There's all kinds of different myths about what caused the Hindenburg to blow up. Some said it was the paint on there. Some said it was static electricity. Some said a guy was smoking a cigar. There's all kinds of different theories. The dirigible, the nickname is the blimp. Usually a cigar-shaped gas-filled bag powered by an engine and steerable. If they lost gas while in the air, they would fold in half. If sparks from the engine ignited the gas, they would go boom.
Go boom.
The Zeppelin. Zeppelin was a German count who worried about air attacks from French dirigibles. He studied the dirigible construction and made several innovations. Zeppelins had several gas bags instead of one. A rigid frame kept the craft from collapsing. Okay? Zeppelin, like a dirigible, like a blimp. Okay? If you heard of the band Led Zeppelin, that's like an oxymoron. Lead is very heavy. Zeppelin, very light. Okay? Kites. Down at the bottom here, to understand the theory of flight, it helps to know how and why a kite works. There must be air blowing over the kite. The air comes from the wind or a small person running and dragging the kite through the air. A tail helps keep the kite at the right angle. If the angle's not right, the vacuum will not form and the kite will not rise. Okay, we're getting to the fun stuff now. Right up here on the top of page 5. Sir George Cayley is given credit for several innovations used on modern airplanes. He replaced the main glider kite with a pair of wings. They were bent up to keep the plane from turning over on its side. This is called lateral stability. Because the wings were flat, the glider wouldn't go very far. Cayley decided to curve the wings to smooth the airflow. The curved wing is said to be cambered. The curved wing or airfoil provides the lift, which makes it possible for planes to fly in the air. Most of the lift is a result of the airflow across the top of the wing. Now, here's where it all comes into play. How many of you heard of Bernoulli's principle? 1 or 2 or 3? Okay. Seems complex, but really it's not that bad. Bernoulli's principle. The static pressure of a moving liquid varies inversely to its velocity. Translated in simple terms, it means that air loses pressure when it is speeded up. Testing Bernoulli's principle, hold a piece of paper in your hand, making a slight airfoil blow across the top. What happens? Blow harder. How does this affect the paper? Okay, in other words, I take a piece of paper, I blow across the top, the paper rises up because the air going over the top is moving fast, so it has less pressure, and that causes the paper to lift up. Okay? This is not that complex of an idea. Let's look at the picture at the bottom of the page. Under the airfoil, it says Cayley's wing or airfoil was called a simple camber. Most modern airplanes have double surface airfoils. If you understand Bernoulli's principle, you will understand that when air rushes over and under the wing, the air that flows over the top has a longer distance to travel than the air going under the wing. Therefore, the air moving over the top has less pressure than the air moving past the bottom. Higher pressure air under the wing lifts or pushes up against the wing. When air moving over the wing isn't fast enough, the lift isn't great enough to keep the plane in the air, and it will stall. When this happens, the plane begins to fall towards the earth. Look at the picture right here. This explains it best. Air passing over the top of the wing has a greater distance to travel. Therefore, pressure is lower on the top of the wing. Does that make sense to you?
You still teaching?
I'm still teaching. And we're recording. So you can watch this on YouTube if you missed this lesson. Have you heard of Bernoulli's principle before, Mr. Wilson?
I've heard of it, but I don't know anything about it.
Okay. Watch and see if you can understand this by the next 10 minutes.
Okay.
Okay. This is the picture the book gives you. They say low pressure here. Here's the airfoil. Air passing over the top of the wing has a greater distance to travel. Therefore, pressure is lower on the top of the wing. Here's the airfoil on the wing. Bernoulli said as the speed of air increases, the pressure decreases. Okay? So you have a wing going through the air. It's pulled forward by the propeller. The air is split by the wing. Some of it goes over the wing. Some of it goes under the wing. Since the air, consider it like a colored smoke, is separated at the front of the wing, it meets up again, that colored smoke, at the same time on the back of the wing. The air going over the top of the wing has a lot farther distance to go. in the same amount of time, so it has to go faster to beat the air on the bottom of the wing. Bernoulli's principle says as the speed of air increases, the pressure decreases. It's low pressure area on the top of the wing, high pressure area on the bottom of the wing gives the plane lift. It's literally pushing up on the bottom of the wing. So the propeller gets the plane going down the runway where the wing divides the air in half. Some goes over the wing, some goes under the wing. The air going over the top of the wing, since it's curved over the top, has a farther distance to go, so it has to go faster, but in going faster, it loses pressure. The air on the bottom is going slower, so it has higher pressure. It literally lifts up on the bottom of the wing and pushes the plane into the air. At some point, you have enough air going over and under the wing, it will begin to fly. A plane like that one over there, that radio control plane, will not fly if it's just sitting there. If you cut the wires, it's going to drop to the ground like a rock. When it gets moving down the runway, and you get that, it all comes down to the difference in air pressure. The air starts going over the wing, starts going under the wing, and then it creates lift and the plane lifts up off the ground. So as long as you keep that air going over and under the wing, it will fly, unless you go so slow that it's going to stall. Now see if this makes more sense now when you look at Bernoulli's principle. Here's the picture. There's the low pressure on the top. You can see that air has farther to go. Air passing over the top of the wing has a greater distance to travel, therefore pressure is lower on the top of the wing. And it's higher on the bottom, pushes it up. Here, that paper's heavy. It won't move unless I blow air across the top. That's the easiest example of lift I can show you. I'm blowing air only over the top. I'm not blowing it under it. I'm just blowing it over the top. That air moves real fast. Low fast air, high pressure area underneath. Okay? I should have said fast air, low pressure on the bottom, higher pressure lifts up and pushes on the wing. Okay? So now look at this. Air passing over the top of the wing has a greater distance to travel, therefore pressure is lower on the top of the wing. Cut. Bing.